Okay. Hi everyone, we are from Group 1. Today we are going to talk about cosmogenic nuclide dating. This is our group members' name Hanani, Sachikashri, Bavadarni, and Shafika. Today we are going to discuss about what is cosmogenic dating, what are the advantages of cosmogenic dating, what is cosmogenic dating in glaciers geology, and what are the difficulties in cosmogenic dating. Now we are going to look about what are cosmogenic dating. Cosmogenic nuclides are rare nuclides that are formed in surface rocks because of bombardment by high energy cosmic rays. When isotopes in rock crystals are bombarded by these energetic cosmic rays, neutrons, a spallation reaction results. The reaction resulted in the formation of cosmogenic isotopes. Counting the numbers of these isotopes, normally as a ratio to other isotopes, means that scientists can calculate how long rocks have been exposed at the Earth's surface. Cosmogenic nuclides are used for determining the age of geological events or landforms in two different ways, which is exposure age dating and also burial dating. Simple exposure ages rely on the buildup of cosmogenic nuclides in sample at the Earth's surface at a known rate over time. In contrast, burial dating relies on burial and shielding from cosmic rays of the material being dated after initial surface exposure and the contrasting half-life of at least two nuclides.
So now we're going to talk about the advantages of cosmogenic dating. Yes. So these are the few advantages that we can find in cosmogenic nuclide dating. The first one is it can be applied to a wide variety of carbon-containing materials. The both organic and inorganic materials can be dateable. It has shorter half-life, which means it has more accurate age estimation. And lastly, it is effective over short to long time scales. Next.
Next, we'll be going through a bit on cosmogenic dating in glacial geology. Next. So, glacial geologists use cosmogenic dating to date glacial landforms such as erratics or glacially transported boulders on moraines. And dating glacial landforms actually helps the scientists to understand the past ice sheet extent and rates of ice extension. And cosmogenic nuclide dating can also be used in this context to understand the past ice sheet thickness and changes in subglacial thermal regime. Therefore, this helps scientists to relate the phenomena with climate change. Next.
Next, we will see what are the difficulties in cosmogenic dating. Next. The first difficulties is exhumation and burial. This is because periglacial environments are subject to strong rock cycling within the active layer, which can bury or exhume boulders, leading to inaccuracies in the estimated exposure age. Second is rolling and rotation. Landforms such as moraines are subject to degradation, and anything on a slope will move to downslope under solifluction. This causes previous hidden faces of boulder exposed and lead to error in age estimation. Third is inheritance. This is where the boulders not undergoes sufficient erosion to remove accumulated cosmogenic nuclei that result in older than expected age. For example, in Antarctica, this is because there erratic boulders transported slowly that apply minimum erosion. Next. Fourth, burial by snow, where it happened due to windy, but if the boulder exposed above the land surface, then it will not be a problem. Next, dating one boulder only. This caused the method to be unreliable, and scientists may screen for complex exposure using two different isotopes, which is aluminium and beryllium. Lastly, topographic shielding. This is cause the sky to shield it, and the cosmic ray which bombard Earth will be reduced and affect the production rate of cosmogenic nuclei. Next. This is picture showing solifluction loops on the Ulu Peninsula and the frost heave in periglacial environment that bury and exhume result in complex exposure age. Next. This is our references. Next. That's all from us. Thank you.